Hey guys, I'm Pat Kelly. Okay, in this problem, they describe a C to you, and then they ask us to evaluate this integral. And I've already drawn the C. If you notice, the way it's given to you is they just give you these 3 points, the 3 pairs, ordered pairs. It ends up being a triangle. I think they might even mention that. And they do specify that the direction we would travel around the sides of this triangle is counterclockwise. So I've tried to indicate that as well. All right. And then the first part of the problem, part A, does ask us to parameterize this. Easier done than said, I think. But we're going to parameterize this. And then second part of the problem, part B, is to actually evaluate that. Okay. So to begin, in order to parameterize this, I'll go piece by piece. In fact, let me first even label the 3 legs of our journey. Is the bottom side of the triangle would be C1, and then I'll address that hypotenuse as C2, and then that left side as C3. I'm just trying to give you some bearings to line up with my work. Is I'll do 3 parts to my work. First, I'll try to address this C1. When I go to parameterize it, I got to think about what the x coordinates are doing and what the y coordinates are doing as I travel along this path. My x is going from 0 to 1, so what I would do for x of t, all of our parametric functions here dependent on t, so I think I would just make x of t, t. And that should make sense to you if I slide over just a little bit and realize that t will go from 0 to 1. I suggest it should make sense to you if you think your x's are going to go from 0 to 1. Just let x be t, and then the t's go from 0 to 1. Okay? And the y coordinate in that first stretch of our journey is 0, and it's always 0. So my y of t is just going to be 0. All right, similar thinking for each of these other 2 sides of the triangle for my C2 here. Similar thinking, but different work, of course. I've got to think about what my x coordinates are going to do. They're going to go from 1 up to, over, I guess, to 0, okay, the x coordinate. And then I got to figure out how to express that in terms of t. And I definitely want to think about what my t will be. So I'm going to slide over a bit and first get a handle on what my t domain is. You definitely want to pick up where you left off. I'll try to make sure I have enough room. So I'm going to pick up at the 1, and it makes sense to maybe just go to the 2. Your answers may vary, but I think this makes sense. All right, now in order for my x to start at 1 and then go down to a 0, I'm thinking about 2 minus t. Make sure that makes sense to you then, is when t is 1, I plug it in and I do get 1. When t is 2, I plug it in and I do get 0. So I think that works. And I also need a y of t. And my y's I have to be thinking need to start at 0, but then go up to 1 when my t is going to go from 1 to 2. So I think I would try t minus 1. And you see if that makes sense. Plug a 1 in, I get the 0 I want. Plug the 2 in, and I get the 1 that I want. So I think that works. And then c sub 3, finally. I need an x of t and a y of t. But I definitely want to be guided by what my t values will be. So I'd probably start over here again and get that restricted domain. Pick up where you left off. And it makes sense to go up to 3 in this case. Again, answers may vary. I think that makes sense. Now I got to think about my x coordinates on that third leg. Start at 0 and end at 0. So x of t is just 0. That's good. And then my y of t have to start at 1. My y values have to start at 1 and then go down to 0 when t goes from 2 to 3. So I think 3 minus t works, but I check. I put in a 2, I get the 1 that I wanted. I put in a 3, and I get the 0 that I wanted. Okay, take a breath, pat yourself on the back. That's your answer for part A. You've parameterized that C that they gave us. Okay, good. Next, they want us to evaluate this. I should have even explained a little bit that I wrote that in purple. That's what's given to us in the problem. I gave us a head start on how to do that in pink. This integral will equal this guy, and we put in our specifics, okay? So I'm going to end up taking this f function. Let me even grab pink here, because this f function comes from right here. All right, that's your f of xy. So I put in my specifics for that f function using our parametric equations. And then there's also this component you don't want to forget, which is one of the main reasons I wanted to give us that head start, is you need to see this component, this piece of the puzzle, in each of your integrals. I'm going to do a derivative, square it, and all of that's going to be under a square root. Okay. Now the next thing is, let's actually get to this and try working it out, is to do that integral of 3 different pieces means 3 different integrals. Okay, so I need to do 3 different integrals, and each one will correspond to one of our c sub whatevers. Okay, so I'll first do c sub 1. Let me even label maybe my work. This is scratch work. For c sub 1, this is what the integral is going to look like. The limits of integration, a to b, those come from your t values. I'm going to go from 0 to 1. That f of, we take x of t, which in this first branch is just t, and we put that in for x, the first coordinate, the first input, which is right there then. So I end up with a 2t for that, plus 3 square root of y, but what you're plugging in for y is the y of t, which is 0. So that's not there at all. Then multiply by this component. I'm going to do some differentiation in my head, maybe even a little bit of arithmetic, because you'll see it's not too bad for this one. X prime of t, differentiate this. Derivative of t is 1, but square that is 1. The derivative of y, well, the y was 0, so you're still getting a 0. Squared, it's all 0. This all ends up being the square root of 1 for me in this first branch. Okay, and dt. Okay, I think I'm actually even going to evaluate that. That's still just the first branch. I'll do the other 2 branches. So this looks like t squared from 0 to 1. You got to love your 0s and 1s. Makes this all easy arithmetic. I get 1. Moving on, I need to do similar work for c sub 2, an integral. My limits of integration are going to be from 1 to 2. I want to think through the exact same setup as I did for the first branch. It's just the expressions are going to be a little bit more involved. So f of, and I'm putting x of t, which is this guy, 2 minus t. I'm putting that in for x into this function. So I'm going to have a 2 times this, x of t. So I'm going to write that as 4 minus 2t. That all comes from right there. Plus, from right there. And then I'm looking at, well, there's a 3. I'll go ahead and write that. And there's a square root. But then what you're putting in for y is y of t. So I need all of this in there, the t minus 1. And that's under the radical. And we put some parentheses around all of that. Because then the next thing I'd want to do is that component with the square root. And I'll do some differentiation in my head again. It's again not too bad. Prime of x here is just a negative 1. Differentiate that with respect to t. But it's squared. So I'm thinking, hey, that's a positive 1 right there. Plus y prime. I'll differentiate this. That's 1. That's squared. So I'm getting 1 plus 1, that's 2, and then there's a square root. So I do have a factor of a square root of 2 here before the dt. Okay? All right. And I think I'll try to go ahead and evaluate that as well, just like I did above. So this is going to equal, I would pull the square root of 2 all the way out in front, and then I'll integrate each of these. Anti-differentiate, and I'll get 4t minus t squared plus, and then I'll be careful with this one, that t minus 1 is to the 1/2, so it's going to bump up a power. T minus 1 is going to bump up to the 3/2 power when I anti-differentiate. Divide by 3/2, which is like flipping and multiplying by 2/3. See, the 3 is going to cross out with the 3 that would have been downstairs, and you end up with a 2. If you never trust me on anything, you should check then. I think it should work out. Maybe you'll end up trusting me then. The 1 and the 2 for my limits of integration, I still need to plug in. So I'm going to do that as well. Plug in the 2 first. First, I guess, I'll do the square root of 2. And then plug in that 2. Arithmetic. 8 minus 4 is 4 plus, and if I put the 2 in here, this works out well that that's a 1. So this is just 1 times 2 is 2. So 4 plus 2 is 6, minus, plug in the 1, 4, take away 1, which is 3, and this is all 0, so that's good. That wasn't too bad, I guess. We get 3 square roots of 2. Whew, almost done. Let me move over here and get my c sub 3, and again, very similar thought process. Here's my integral. We'll go from 2 to 3 this time. And then I'm looking to plug into this function, 2x plus 3 square root of y. I'm looking to plug in your x of t and your y of t. X of t is 0, so that's nice. That's going to blank out. My y of t is this 3 minus t, so I'm going to have the 3 times the square root, 3 minus t. Then I need to multiply by that square root component. So if I differentiate that 0, that's good. If I differentiate this, I get a -1, but squared is +1. Under square root is all still 1. So I'm ready for my dt here. And I'm ready to integrate. This equals 3 minus t. Here's another 1/2 power deal where I would bump it up to the 3/2 power when I anti-differentiate. And then it would be divided by 3/2, so multiply by 2/3. So the 3's are going to cross out again. I would have a 2 there. But be careful, because that t inside the parentheses has a minus in front of it, you would have a minus here as well. It's a U substitution problem really from a long time ago. So this would be my integral. I need to evaluate from 2 to 3. Let's go ahead and do that. I would have, I'll do the -2 first. When I put in the 3, this works out well that that's a 0. Okay. And subtract what happens when I put in the 2. Works out pretty well as well because that's going to be a 1. Raised to that power is just 1. So I have a -2 times a -1 is +2. And oh my goodness, I think we've got it. This is our final answer here then. I'm going to use this little bit of space I have here just to write my final answer, which is just the sum of those 3 integrals. Okay, so this is what they asked us for. And this ends up equaling, where's the first one? 1 plus 3 square root of 2 plus the 2. And I guess I would simplify a little bit and say 3 plus 3 square root of 2. And then go take a break. Because we got the right answer. I feel good about it. Practice some on your own.